Okay, so that's kind of the background of where these views came from. So now let's talk about a simplified version of their model. Okay? And so remember that it's going to be a model that's really stresses this search process. Okay, so there's going to be workers and there are going to be firms, and they're going to enter the labor market to try to match with one another. That is, workers are going to try to match with a firm, firms are going to try to match with workers so that together they can produce some output. And what's going to be interesting is that obviously some people won't be successful at matching immediately anyways. Okay, and again, this is because this search process takes time. I might not find a job today. I might find one tomorrow, but I won't necessarily find it immediately. So, I'm sorry, there we go. Okay, so there's going to be n potential workers. You can think about this as being, all working age, the working age population is n. And there's going to be q who are going to rationally choose to be in the labor market. So when I say rationally, I mean they're going to compare their options here. Some people are going to choose, because it's better, to go into the labor market and try to search for a job. And of those who go into the labor market, as I said, some fraction will find a match, i.e. find a job and become employed. And then some other fraction will not find a match and will be unemployed or will still be searching, right? So this is like a one period model, a static model. It takes place in, I don't know, you could think of a few weeks. I'm unemployed, and over the next few weeks, what's the probability that I'm going to find a job while I'm searching? And likewise, you're going to have firms, okay? And there will be active firms who choose to enter the labor market and search. So again, they're going to make this rational choice. And importantly for us here, we're going to make this simplifying assumption that each firm offers one job. Okay? So really when I say there are A firms, what I mean is there are A positions being offered. And just as I said, for simplification, we're going to assume that each position is offered by one firm. And now again, some fraction of firms will find a match and some fraction won't, and we'll continue looking. So here it's a two-sided model in the sense that both workers and firms are looking for a match. Okay, firms are looking to match to workers and workers are looking to match to firms. And in both cases, they might be unsuccessful in this period. And importantly for us, decisions are micro-founded. Remember we said modern macro is all about micro-founding. Okay, so decisions made by these workers and these firms are going to be rational decisions, ones that maximize their expected outcomes, their expected utility or expected profits. And here they're going to make one decision. The one decision that both firms and workers make is whether or not to enter the labor market and search. Here's my diagram. So, this is saying exactly what I just said. So we have n consumers. This is the potential labor force. That is, it's all people of working age in the population. Okay, n. And some fraction of them, these blue ones, q, are going to enter the labor force to search for a job. Okay, they're going to enter the labor market and look for a job to try to match with firms. There's an infinite pool of potential firms. Okay? But only A of them will become active. So that is, only A of them will post a job, post a wanted ad looking for a worker to match with. And importantly, as I mentioned, these two decisions are going to be rational. Okay, so the decision to enter the labor force is going to be rational in the sense that each worker or each potential worker compares the benefit of being out of the labor force to the benefit of being in the labor force, and then rationally makes up their mind. And likewise, firms, it's going to be a matter of I'll enter if I expect that I'll make profits. If I don't expect that I will make profits, then there's no point in trying to enter, in posting a job. Okay, so everyone enters the labor market. We have workers on one side, firms on the other, and then we have the matching process, which I'll talk about more on the next slide, in which randomly some set of workers and firms will be matched. Okay, so each one of these pairs of workers and firms is now an employed worker. with a given firm, but some fraction of firms and workers will be unmatched, and they'll continue searching. So as I said, matching is going to be random. So the number of matches is going to be determined randomly by the matching function. Or that is, the determination isn't random, but rather whether or not a single person matches or a single firm matches will be random. So what's this matching function? Well, it's going to take the number of people in the labor force, the number of workers in the labor force, Q, and the number of active firms, and it's going to tell us, given that information, how many matches there will be. Okay? And E here, so M is the function. E is the matching efficiency. E is a parameter. So you can imagine the higher is E, the more matches we would expect for a given Q and A. Okay? And I'm going to make some assumptions now about this matching function. And I'll argue that they're pretty reasonable assumptions. The first is constant returns to scale, which we saw already, right? Which says if I multiply both inputs by some number, x, then the output also increases by that same number, x. But that is by a factor of x. And this is pretty reasonable, right? I mean, if I double the amount of firms who are looking and workers who are looking, on average, I would expect the number of matches to also double. So it's kind of this size independence, right? If I have a small labor market, then I would expect proportionally less matches than in a large labor market. But adjusted for the size of the labor market, they're probably the same, right? This one also makes sense. This says if there's no consumers or no firms, then there's no matches. Okay, this, I mean, probably doesn't require any explanation. Obviously, if there's no firms, then workers have no one to match with, and there will be zero matches. Likewise, if there are no workers, then firms have no one to employ, and there will be no matches. Okay, it's pretty straightforward. The number of matches increases in Q and A. Okay, so as I increase the number of firms who are looking, as I increase A, on average, I'm going to expect there will be more matches. Okay, just by chance, now there's more firms looking, so on average, there will be more matches made. And likewise, if I increase the number of workers who are looking, we would expect to see more matches, right? Because there are just more workers looking. It's just more likely that some of them are going to find a match. And finally, we have this decreasing marginal products, which means that the second derivative will be negative. Okay, so the additional effect on matches of adding another firm or another worker, keeping everything else equal, will be smaller than adding the last one. Okay, so the effect is decreasing as I add workers. And again, this kind of makes sense, right? As I add workers, the number of matches will increase slower, because you can imagine, you know, I keep adding more and more workers. Eventually, each firm will find a worker. And as I add more workers, obviously they're not going to find more firms. All the firms are already taken by a given worker. It seems reasonable. And now you might say, hey, these sound kind of familiar. And in fact, that's because they're basically the same assumptions we made on the production function. Okay, and in fact, often we use the same functions. So a really common candidate for the matching function is Cobb-Douglas. So you might recognize that we use this a lot for the production function. If you replace Q with K and A with N, this is just the production function. Now, this CRS, the constant returns to scale, ends up being very important for our model. And the reason is because of CRS, we're not really going to have to care about A and Q per se. We're just going to have to care about their ratio, A over Q. That is the number of firms looking for a worker over the number of potential workers. So why is that? Well, think about this. For example, what proportion of workers find a match? okay? And I call that PC, okay? That's the percentage of C consumers or workers who find a match. And so that's just the number of matches divided by the number of total workers looking for a match. Okay, so if there are 100 workers looking for a match and 50 of them match, then 1/2 match, right? There's 1/2 of workers who find employment in this period. And so now we can start kind of substituting things we know. So we said that M is just given by this matching function. So we put that in. And notice that dividing by Q is the same as multiplying by 1 over Q. And now because of the constant returns to scale nature of this function, we can just bring this inside the brackets. Okay, so multiplying the whole thing by 1 over Q is the same as multiplying each argument by 1 over Q. And then simplifying, you get the following. With the percentage of workers who match is just given by the matching function evaluated at 1 and j, where again, j is this ratio of active firms to consumers, or that is to workers, looking for work. And I think here this makes sense, right? All else equal, if we double the amount of searching workers and active firms, the number of matches doubles. Okay, and therefore the proportion of people who find matches stays the same. So if I double A and Q, J stays the same, right? And so it makes sense that for any, if I have A or Q or double A and Q, the percentage of workers who find a match will still be the same, because not only am I doubling the number of workers, I'm also doubling the number who find a match. Okay. So doubling A and Q both doubles this numerator and the denominator, leaving the proportion the same. And the same thing holds for the proportion of the proportion of firms finding a match. Okay, the probability that a firm finds a match. So again, let's do the same math. So the proportion of firms who find a match is the number of matches over the number of firms. Okay, so if there's 100 firms looking and 50 of them find a match, then again, this proportion would be 1/2. And again, let's plug in what we know M is, this matching function. Do the same thing where we can put the A inside the brackets. And what do you get? You get that again, the proportion of firms who find a match is given by the matching function evaluated at 1 over j. So remember in the last case we had j, in this case we have 1 over j and 1. So again, what really matters is j, not the actual A and Q, but their ratio. And so let's just talk for a second about why this is. Okay, it's reasonably intuitive. J is referred to as the vacancy rate. It's the number of vacancies there are per searching worker. The number of possible jobs available for the workers who are looking. Okay? And it's also a measure of how tight the labor market is. So what do I mean by that? Well, the higher is J, the more tight is the labor market. Okay? So when we talk about tightness, we're talking about from the perspective of the firm in this case. The higher is J, the fewer workers there are per firm. And so it's harder for me as a firm to find a worker. And that's what we refer to as a tight labor market. Hard to find a worker because there's so few relative to the number of positions available. So the higher is J, the more firms per worker there are, the more tight is the labor market. And so now let's look at these proportion of consumers who match, okay? PC. Or you could also say proportion of workers who match. As J increases, there are more available positions per worker. Okay? That's just the definition of J. If it goes up, then for a given number of workers, there's more positions available. There's more firms looking. And therefore, firms are more likely to find therefore workers are more likely to find a job. And that's what we see in this function, right? The matching function is increasing in both of its arguments. So as J goes up, the probability of finding a job for a worker also goes up. PC also goes up. And the opposite is true for firms. Okay? As J increases, there are fewer workers per available position. Okay? As J goes up, that means there are more firms looking for a given number of workers, and therefore there are just fewer workers per available position. The labor market is now tighter. And therefore firms are less likely to find a worker. Okay, there are just fewer workers looking for any given job, and therefore I'm less likely to find a worker. And so that's why here we have 1 over J, right? Again, remember this matching function is increasing in both of its arguments. As J goes up, this term goes down. And therefore, the probability of a firm matching, probably of a firm finding a worker, goes down.